Hi, this is DeepSeal, a confidential RWA due diligence vault built on Chainlink CRE. The core problem we're solving is that real-world asset onboarding depends on opt-in verification. Things like document check, KYB providers, risk analysis, but those checks usually happens in fragmented backend system that are hard to trust, hard to audit, and not deterministic from a protocol perspective. And that's where the CRE comes in. DeepSeal uses one CRE workflow as the trusted execution layer that reads on-chain request, call external service securely, plus deterministic decision logic, and it writes everything result back on-chain. In the protocol architecture on a very high level, we have multiple contracts deployed on-chain. We have the CRE workflow in details. We have our vault. We have document verification provider as some sub, and we're using X402 micropayment for the payment to our provider. We are using Gemini for risk score. Yes, attestation for immutable compliance decision storing. ERC 8004 for reputation and validation feedback records. This is how Chainlink is used here. Most importantly, the confidential HTTP is used in 4 of the components. It has 11-step workflow. It reads on-chain request for RWA document verification. It resolves the IPFS data and extract all the data from the document. It sends it to the KYB verification endpoint for verification with X402 USDC micropayment. After the result, we do a PII redaction for removing the sensitive content from the document to send it to the Gemini API for scoring. From the KYB verifier and Gemini API, we get a merge decision score. We write everything on-chain as a report and compliance registry update that, and we do update our EAS registration and ERC 8004 validation reputation feedbacks. And finally, for off-chain audit trails, we do a confidential audit webhook. This is the demo of a protocol DeepSeal. First, we'll go to the submit request section. We'll submit a diligence request for all the verification of our RWA asset. So here we are using a demo data for the document purpose. Here we have all the dummy details with the company name, industry, and with other factors. We'll submit the request. And fine, the transaction is being broadcast on chain, as you can see. Now, before I go to the process, let's go to the compliance section, look for the address, and it's not compliant yet. Now I can load our request. We have all the data over here. Now I'll start the CRE workflow, and when it's done, I'll explain you all the steps involved in that. Fine, the process is completed. We have all the outputs. Let me explain one by one. First, it builds the trigger payload for the Chainlink CRE workflow. In this case, it's using the request we've already submitted. Second step is skipped because it's for Anvil only. And we initialize the CRE simulation. The first real step is reading the request from chain. It pulls the original request from the on-chain contract. So it gets the address, document hash, and the metadata URI that points to the submitted document bundle. After that, the workflow resolves and verifies the document bundle. It fetches the file from metadata URI, checks that content match with the hash committed on-chain, and it extracts all the business fields like company name, country, and hash. After that, it runs the KYB verification. In our case, we're using some sub free tier API. And because it is a paid verification route, the workflow also settles the X402 micropayment. So the micropayment pays 0.01 USDC, and this is the payment transaction hash. Then we go to the next step. It runs a PII redaction step through confidential HTTP. This removes the sensitive field before we send any data into our AI scoring page. And now we run the AI scoring via Gemini. It receives the clean redacted business context plus the verifiable KYB output, which is approved, and it gives us a risk score out of 1,000. So Gemini says it's rejected, but because of the many field which is being mocked and dummy. But just to show you the demo, I have hard coded it to be approved. Then it merges the final decision, which is simple. The request only passes if both the KYB result and the AI result pass. In this case, both are positive, so final decision is approved with a combined score of 300. Finally, we encode the workflow report and we send a confidential audit sync through confidential HTTP. Then we broadcast our final report on chain. Here is the transaction. And after that, all the side effects we can see. The vault asset is being created here. And then there is the ERC 8004 agent score, which is 70 out of 100 for both of the agent. We can re-verify that. I'll go to the feedback section, and this is the transaction and the score is 70, and in the overview we can see the overall score over here. Same for the validation agent. We get a feedback here as well. Now we'll go back. Here is the hash of the EAS attestation on chain. Finally, here are all the events, and these are the raw terminal output is being generated here. Now, if we go to the compliance section B, if we look up for the address, and it says that it's approved. Finally, the vault operation is open for us. Let us select an asset. Our asset was 6. I have already approved some amount. I'll go do some deposit here. And done. We got a share of our RW asset, and we'll view the transaction here. It's been done, and the asset is being transferred to me.